Okay, let's dive into this explainer. Today, we're looking at the architect's memory, specifically data warehousing and database structures. We're going to break down the absolute foundational blocks of digital memory and jump straight into the high-stakes choices developers face when they are building the invisible infrastructure all around us. It all starts with one core mystery. How do computers actually remember everything? Now, the real question isn't just about simple recall. It's about how modern infrastructure scales that memory up to handle the immense, crushing weight of the modern web. Think about it. Every profile, every message, every single transaction. How on earth are they stored and retrieved without completely collapsing the system? Section 1, the heart of the app. Because really, this digital infrastructure functions almost exactly like a living organism. Digital memory and the practice of data warehousing is essentially the vital core of every major application. It's the engine enabling the storage and retrieval of absolutely vast amounts of information. We all know this is the foundation, right? But fully grasping this foundational layer is critical to understanding the massive architectural split we'll be looking at in just a second. Because data literally is at the heart of every significant program. Every single app you rely on every day uses this data as its beating heart. It's not just about simple storage, you know? The specific way that data is housed dictates whether the application survives or fails. The architecture chosen here is the absolute lifeblood of the software. Section 2, SQL, the structured library. And this brilliantly illustrates our first major architectural philosophy. The source material draws an incredibly insightful analogy here. Relational, or SQL, databases are organized like a giant, interconnected library. So instead of just random, messy piles of data, you have these perfectly aligned aisles, categorized shelves, structured index cards, and a highly logical mapping system. It places an absolute premium on strict organization and totally predictable structure. A relational framework basically means different tables of data are explicitly linked together. And because it functions as that interconnected library we just talked about, it remains incredibly organized, with a primary focus on structured data retrieval. A developer is going to choose this path when they need absolute foundational stability, a setup where every single piece of data has a known relationship to another, and absolutely everything has its proper designated place. Now, what's really interesting about this slide is it presents a fundamental fork in the road for database architecture. On one side, we've got SQL offering that perfectly organized, interconnected library, but on the other side, NoSQL provides flexible storage designed for rapid changes. Developers are constantly having to weigh this trade-off. Do they need the strict, predictable order of the library, or do they desperately need rapid on-the-fly flexibility? Section 3, NoSQL, built for speed. Now, if SQL is the quiet, meticulous librarian, NoSQL is the totally dynamic, fast-paced trading floor. It completely relies on flexible storage designed for rapid updates. In a lot of modern web environments, data just isn't always neat and predictable. When the types of data you're storing are constantly changing, or when the sheer volume of updates is just off the charts, that rigid library structure actually becomes a huge bottleneck. You need a system that bends rather than breaks. Let's move to and see how this builds. The mechanical process here is incredibly agile. First, rapid changes are initiated by the application. Second, instead of checking against some rigid index of relational tables, the flexible storage adapts instantly to the new data format. And finally, the information is updated without any delay. This agility is exactly why NoSQL is the absolute go-to architecture when speed and flexibility are your highest priorities. Section 4. Surviving the traffic surge. This is where things get really intense. So, why does all of this abstract theory actually matter? Billions. The systems we're talking about aren't just serving a few people at a time. These architectures literally have to support billions of concurrent users accessing their information instantly. This moves us right out of abstract database theory and straight into the dramatic, high-stress reality of modern web traffic. Look at this high-stakes reality. With billions of concurrent users demanding instant information access, the stress on these systems is almost unimaginable. Profiles have to load immediately. Messages must send in real time. Whether they're utilizing the structured library of SQL or the flexible speed of NoSQL, the architecture must maintain absolute stability and speed. Under this kind of massive stress test, efficient data management is literally the only factor preventing a total system crash. Without it, the application simply dies under the crushing weight of the traffic. So the crucial point is, we can see a clean synthesis of this whole architectural divide. SQL utilizes a relational structure, acting as that interconnected library best suited for strict organization. NoSQL shifts over to a non-relational model, functioning as flexible storage optimized for rapid changes. Understanding this core trade-off is absolutely key to grasping how modern digital memory is built to survive. Which leaves us with this. If digital memory truly is the heart of every app, what happens to our data when the architecture finally fails? It's a high-stakes, incredibly fragile digital world we navigate every single day, and it is entirely dependent on these invisible, brilliant structures holding everything together. Thank you so much for joining me on this explainer, and we'll catch you next time.